I'd say half of our team mostly uses Claude Code at this point. A lot of stuff is kind of kicked off with Claude Code, and that gets you 90% of the way. And then the final 10% you sort of finalize with something like a cursor. But I'd say the other half of the team is like all cursor.
Yeah. What about you personally? What's your workflow?
I like to like start things off with Claude Code and then kind of take it the final mile on cursor.
Now you're in New York. Is the whole team in New York?
Yeah. So all of engineering is in New York. All of our growth and sales is in San Francisco. I find that even the location split is sort of helpful in that like one office is sort of entirely thinking about sales and growth and content ideas and that sort of thing, and one office is sort of entirely focused on product.
Did your idea change much in YC, or did you go in with pretty much this idea and come out with this idea?
I think we were one of the only companies in our cohort, at least, where we came in with this exact thing and we are still kind of building this exact thing.
What's up, everybody? This is Alex. Great episode today with Aayush Shah, who's one of the 3 co-founders at Blacksmith. And Blacksmith is like a CI runner for GitHub Actions, right? Provides the compute fabric, so a much faster CI solution, while also giving you like this interesting observability into like test history and let you know like, hey, did this test fail because I wrote some bad code, or because it's like a flaky test and it fails, once out of every 5 runs anyway, right? And gives you some visibility into that. But one thing I liked the most was him talking about just like how these AI coding agents have changed CI requirements, especially like if you're out there spinning up 10 different agents working on things at a time, it's like very bursty when all of them finish within a few minutes. They all want to spin up CI to see if it works. And it's just like you have this very bursty CI solution that can be tricky to handle, and just how they're handling it, and pretty interesting stuff there. So be sure to check it out. As always, if you have any questions, if you have any comments, if you have any guests that you want to have on the show, feel free to reach out to me. I love hearing about those, and it's a great way for me to find people. And with that, let's get to the show. Aayush, welcome to the show.
Alex, thanks for having me.
Yeah, absolutely. So you are one of the co-founders at Blacksmith, and you all came on my radar in the last like month or two because there was this great post you had on multi-tenancy and like running a multi-tenant service, and especially like the economics of it, which I just think is like really fascinating. Like, Mark Bricker's done some good stuff, and just like AWS generally thinks about that really well. And it was cool to see, some other SaaS services do that as well. So I guess maybe let's first start off by just having you give us some background on you and Blacksmith and what Blacksmith is and does before we dive into that.
Sounds good. Really great to be here. So I'll start off with a bit of a background on myself. I started my career, 5 years ago at a company called Cockroach Labs, working on Cockroach DB, which is this distributed SQL database. I worked on a lot of the data placement aspects of Cockroach. So one of their USPs was they would let customers kind of transparently relocate data closer to where the traffic's coming from. Cockroach would also automatically, balance your loadout across the cluster, and it would do so in like a multi-region setup. Like you could have arbitrarily many nodes in, arbitrarily many regions across the world, and it would move shards of data around without disrupting, foreground traffic at all. So I worked on a lot of like those aspects of Cockroach for a while. After that, I had a short stint at a company called Superblocks, which is a internal enterprise internal tool builder. It's a competitor to Retool, if you've heard of them. And at both of these places, and just throughout my career, throughout internships during college, it felt like there were a few problems with regards to like the software lifecycle that just seemed endemic across all of these companies, across all sizes, but particularly bigger companies. And a lot of these problems were around, I guess, like context for code reviews. Which I think is like being attacked in various ways through all these like AI code review tools and like all these like bug bots, that sort of thing. The second class of problems that kind of keeps growing with the size of the team is is CI, both in terms of reliability, the amount of time and effort it takes to keep it up from within the company, and also just the amount of time you're spending waiting for each pull request. Not just in terms of the amount of tests each pull request runs, also just the reliability of the test suite itself. The percentage of flaky tests that start blocking people ends up getting to a pretty problematic place fairly early on in the life of the company. And so that sort of was the genesis of Blacksmith in some sense. We also realized that across me and my co-founders, all of our employers at the time were spending a lot of time and effort maintaining CI infra specifically on hyperscalers like AWS. And when you dive a bit deep into it, it sort of feels like a lot of the trade-offs that hyperscalers like AWS have you make are kind of the opposite of what you want to do for CI. Right? I think the big thing we talk a lot about in our blog posts is this forced bundling of EBS volumes, which is precisely the exact opposite of what you want in CI. For CI, you don't care about durably persisting any of that data because these jobs are ephemeral anyway. For stuff that you do care about persisting, like cache artifacts, you kind of just want a very high performance network link to whatever blob store or whatever storage cluster. But for the jobs themselves, they actually need to be as ephemeral and as low durability as possible. You kind of want to make the opposite trade-off. However, on AWS, instances with local SSDs are a lot more expensive than the ones with EBS volumes. And they go even further in that a lot of the most modern instance types with the newest generation CPUs, they don't even launch the local SSD variants for those SKUs until much later. So I think at the time of recording this on AWS, I don't even think you can get an M7A or M7I instance with, you can't get the D variant, the one that has the local SSD. So we felt like there was something here. So long story short is, with Blacksmith, we're trying to build effectively a hyperscaler specialized on CI workloads. And we want to go beyond just the compute fabric. So the compute layer that makes the right trade-offs for CI is kind of one piece of the puzzle. But in general, the set of problems we want to solve are, how do we make engineers more productive as they're trying to merge code? And how do we, curtail the kinds of problems that keep growing within a company as the engineering team grows, and especially with all these AI code gen tools making it so much easier to write code and write tests. We think the bottleneck is going to shift more and more towards merging code with confidence and doing so without slowing your team down.
Yep, absolutely. Okay, and so are you mostly working with GitHub Actions, or is it sort of all types of CI? It's mostly GitHub Actions?
Yeah, so it's just GitHub Actions at the moment.
Okay. And is that eating the world right now in terms of CI? Is everyone on GitHub Actions?
Yeah, so I'd say a lot of the larger enterprises are still on Jenkins, and we often come across customers that are on Buildkite. Interestingly, a lot of the early 2010s tech companies like Uber, Shopify, Slack, a lot of these types of companies are on Buildkite because Buildkite was at that time, kind of the de facto CI system. No one wanted to use Jenkins. Buildkite was sort of this more modern, sane Jenkins. They also made it quite easy to self-host. As in self-host the infra for Buildkite. And so we come across those kinds of companies a lot. But in terms of where a lot of the growth in the market is, it's pretty much all GitHub Actions. I feel like if we surveyed companies that were founded after 2019, more than 95% of them would be on GitHub Actions.
Yeah, interesting. And so will you build runners that work with Buildkite and things like that? Or are you just hey, that's eventually just going to get migrated over to where we're just focusing on GitHub Actions for a while?
We're gonna do it at some point, but we want to push that off to as much to as far in the future as possible. The way we like to think about this like sort of problem space is anyone can build, like sort of this like undifferentiated compute fabric in some sense, right? Like if you prove out that there's some kind of a market resonance or PMF for a specialized CI cloud platform, anyone can kind of like build that. And that's not where we think we can like differentiate long term. However, if we can de-risk a lot of our more like longer term bets around improving productivity in general, as it pertains to CI, as it pertains to reducing flaky tests and that sort of thing, it becomes much easier for us to in the future translate those learnings to other CI systems. But we think we want to like deepen out on this like one vertical first, and then concentrically expand. And at that point, that becomes a more like de-risked proposition.
Yep. Okay. So you're the second company I've had on. I also talked to Depot about this problem. And like, did GitHub just completely drop the ball here? Or like, why are GitHub action runners just quite bad? Or is it like a certain segment of use cases that they're bad at? Or like, what's going on with like just sort of the native GitHub action runners?
Yeah. So I think there's a few factors at play. I think the big one is that they sort of have perverse incentives to not solve the problem. Just because their pricing model charges by the minute. If they give you faster compute, not only are their costs going up, their customers are spending less money. They're consuming fewer minutes. And with how much growth there is for GitHub, because it's kind of the de facto platform owner for code repositories today, it just feels like there's like a lot of perverse incentives for them to not try to solve the problem the right way. And secondly, internally, I think we view GitHub Actions almost as this kind of low-level orchestration layer for workflows that operate on your repository. And I think GitHub sort of views it the same way as well. Like if you think about the fact that GitHub Actions has been around for all this time, they still don't have like a UI for you to track test results. Like they don't have a way for you to look at regressions in like a particular unit test. You could have been running GitHub Actions for 6 years and you would have no idea how a test suite has kind of evolved over the course of that time. So I think that there's sort of a lot of opportunity in the market to kind of build this observability layer on top of GitHub Actions and kind of treat it as like a low-level workflow orchestration platform in some sense. Yeah.
Yep. Interesting. Okay. You mentioned flaky tests a few different times. And I imagine that's different from just like the pure speed and sort of resource requirements of that you're also solving, but like the test flakiness, I guess, like where do you see that flakiness come in and how can you help customers there? Is that an education thing or is there stuff you can do sort of more automatically without them having to change? Like where does that flakiness come in?
Yeah, I think that's a good question. So I feel like there's many ways you can kind of break that problem down, but let's start with how flakiness even kind of creeps in and what I would even define as flakiness. So there's some test failures that are there's like deterministic, right? Like you run it on a given SHA, someone landed like a bad commit without maybe waiting for CI, and like maybe not all of your CI jobs are required for the pull request to merge. So someone kind of hastily just merged a pull request that had a failing unit test. But the good thing about it is that it always fails. Someone can spend 30 minutes on it and get it fixed up and unblock everyone else. Now, the worst kinds of failures are these non-deterministic like test failures that let's say only fail 1% of the time or 5% of the time. Cockroach actually had a pretty big problem with this class of failures where some of our failures would only happen once you stressed a unit test for like an hour out of like 100,000 runs. And a lot of times a lot of times that was just the test being poorly written, not the logic being tested. The logic being tested was always correct, but the test maybe had some like kind of raciness across the many things it was trying to synchronize. But sometimes it's actually the logic being tested is non-deterministically wrong. So when you have a flaky test that sort of passes and fails on the same shot, on the same piece of code, it's actually a hard problem to determine whether that's a high quality failure that points to a real problem with the system, or just a test that has some sort of like a synchronization issue. Now, with that being said, with our customers, the most common thing we see is customers that have a large test suite of these end-to-end browser-based tests, stuff like Cypress and Playwright and Puppeteer. With a lot of these tests, they're sort of running it by running an instance, like an external instance of their application that sometimes talks to a local database. Sometimes it may even talk to like an ephemeral Supabase instance spun up dedicatedly for that unit test. So it has a lot of these like moving parts. It may have like an external network link involved somewhere, which can let flakes creep in. But these kinds of tests are extremely flaky, and we've yet to come across customers where they have a large test suite of Cypress and flaky tests that's like not flaky. And almost always these are kind of the former type of flakiness, where the unit test itself it depends implicitly on some kind of synchronization that isn't guaranteed by the harness, and that's why it's like flaking.
Yep.
And
are there things that you can do for that, or is it education, or is it just like, hey, that's the nature of Cypress and Playwright and browsers and all that?
So there's a number of things we can do for that, and there's a number of things I think we're gonna have to do for our customers going forward, with the rise of a lot of these like AI code gen tools. Because the good thing about these tools is that, for example, Cursor, Windsurf, Claude Code, they're extremely good at writing unit tests. They are extremely competent at writing, Playwright, Cypress tests as well. However, a lot of teams do not have protections in place that prevents them from merging flaky tests in to begin with. So one of the big things that we're sort of working on is how do we help teams selectively stress only the new unit tests that they're adding to their suite, so that when we detect that you've introduced 5 new unit tests for this new feature that you've been working on, can we stress them for you by automatically detecting that, running them like 1,000 times before they're even allowed to merge in, so that like you're at least preventing the increase of new unit tests being flaky over time, new flaky tests like creeping in. That's sort of one thing. I think another big thing is just helping teams identify flaky tests. And the reason this is actually even more critical, in my opinion, than the first thing, is because the cost of a flaky test isn't just the amount of time it takes to stabilize it. It's the impact it has on everyone else from your team that's trying to merge their PRs, that is confused whether their change broke this unit test that's seemingly unrelated. Like throughout my career, and I'm sure like you've experienced this yourself. You push up a pull request, it has 5 unit test failures or 5 test failures of various types, out of which maybe 3 or 4 seem completely unrelated to your change. And you're left wondering, was it actually my change, or is it just like a flaky test? We want to surface that information as readily as possible. So we want to help customers like score or automatically, rank the relevance of a test failure to their particular code commit, and help customers identify whether a given flaky test is even worth digging into, or should you be digging into these like 2 other failures that are very likely related to your change.
Yep. And in terms of like value prop of Blacksmith, do you think of it as like sort of equal weights of like, hey, these fast on-demand resources to like go spin up a bunch of tests very quickly, and also these like higher level things like visibility into long-term test history and stuff like that? Or do you think like one is like more than the other, or how do you sort of think about that value prop?
Yeah, that's a great question. It's one thing that we think about a lot. At the moment, I think our value prop is still quite skewed towards just the compute. The fact that we let you spin up 3,000 vCPUs in less than a couple seconds. We kind of control this entire pool of compute, and we can handle bursts really well. And that's still a big part of the value prop. The hardware stack that's sort of optimized for CI is still a big part of the value prop. However, over time, our observability story is improving, and that's becoming more and more of a reason we're starting to see customers try to adopt us. And our internal goal is to get the observability piece to a point where customers would use us purely for that, even if the compute fabric wasn't as good.
Yep. And it could be like sort of like what you're saying, like where there's the easy win in visibility of like, hey, someone could try your compute runners and see like, oh wow, this is 5 times faster than what I was currently running. It gets you in the door. But then people don't move away because they love all that historical stuff, and like just being able to see that, they're like, I'm never going to move to a different runner. Or if people go to a different company, they're like, hey, we need to have this visibility that I don't have here now. So just like falling in love with that feature over time, even if it's like not as visible right away, requires some history to get built up before they can see that value.
Yeah, as any vendor will try to do, right? Like you want to leverage the data you have with your existing customers to make the experience better for them over time, make the platform sticky for them, and then that's definitely one of the ways we're sort of thinking about it. And we're realizing that as we get deeper into it, a lot of these things kind of lay the foundations for more higher level things that we can unlock, like this scoring of flaky jobs or flaky failure modes, and helping customers kind of understand whether their PR caused a particular failure or not, was something that just sort of came up in the last 4 months when we built like a global log ingestion system for customers. We started realizing that we can collect failure signatures across their CI pipelines, and based on the frequency of any given failure signature, we can help customers understand whether that's like a flaky failure or if it's something unique to their pull request.
Yeah, for sure. One thing on Cockroach, real quick. I imagine CI for something like Cockroach is like very different from CI for like some of your customers, like Clerk or Bead, like things that are like more like web type applications. Is that true? And are you more focused on like the latter? I imagine the database one is so specialized, but maybe I'm off on that. I guess how does that sort of work?
Yeah, that's a great question. I'd say most of our customers are primarily web applications. I think about 80% of our CI workloads are TypeScript, Jest, like that sort of running unit tests and V tests, that sort of thing. However, the pain point felt by a lot of these systems companies is often it's a lot greater than a lot of companies like Clerk, for example, just because a lot of these companies typically have large Rust code bases, often pulling in a lot of dependencies. Rust is notoriously slow at compilation. It's one of the main things people dislike about the language. And LLVM based languages also end up being surprisingly IO heavy during compilation, which means that if you're trying to self-host CI for those repositories on the hyperscalers, you are really bit by the EBS volumes and local SSDs kind of trade-off that they kind of force you to make. So we find that we find that when we outbound a database company or when they come to us, like they actually have a much bigger problem on average. And a lot of times we can help them, cut their CI spend and CI runtimes down by over 60%.
Yep. Do you so you mentioned 80% of your stuff is TypeScript and Jasper tests, all that. Do you have a sense of what the back end front end split is for those?
Yeah, so I'd say front end is so pretty much because we sell to companies that were founded after 2019 or whatever. Front end is all React. It's all like TypeScript React, and anything else is like an anomaly. And on the back end, I'd say the I don't know if I know the exact sort of percentages, but TypeScript is kind of the clear winner. Golang is kind of the second biggest player. So I'd say it's more like a.
And sorry, I was unclear. I meant like of the tests that are run, how many are like more sort of like pure backend tests versus like running Cypress or Playwright or like a browser based test?
I'd say it's closer to like a 50-50 split. The state of it's funny because the state of front end testing is so poor that because writing component level tests just does not work after a certain size outside of like some very critical complex components that your code base might have. So if you want to have any coverage of your front end after a point, almost the only option you have is something like a Cypress or Playwright test suite. So I'd say within that it's fairly 50-50.
Yep. Okay. One more Cockroach question. I know that Cockroach is kind of specialized. Do you use Cockroach at Blacksmith, like given that you work there, or are you like, hey, it's cool, and I like it, but like we didn't really need it for our specific needs?
No, not at the moment. Although we did have one use case for it where we could have used it, and we might still kind of move to it, but we decided to start off on like a simpler Postgres-based setup, and then the kind of nice thing about all these Postgres compatible databases is the on-ramp, right? Like we can migrate to them when the pain point kind of becomes evident.
Yep. Very cool. Okay, let's talk a little bit about the force bundling, the EBS and EC2 stuff. This is interesting because we also had Sam from Planet Scale on talking about their new Metal offering, and he had like a similar complaint as you, but like a different approach to it, right? Where he's like, hey, EBS is super expensive. But for their workloads, like IO being so important, and still needing some, I guess like they decided running the instance with the locally attached NVMe makes sense for them. Actually is a lot cheaper than using EBS. But for your needs and requirements, it's like that's still just way too expensive to do that, is what you're saying, given your sort of requirements in CI.
Yeah, so there's a number of threads we can dive into there. I think like the big part of our thesis behind Blacksmith was that CI as a class of workloads does not need to run in a customer's cloud account. So for example, in your conversation with Sam, he mentioned how like if you're building a database, if you're a database vendor and you're not on one of the hyperscalers, it's sort of an immediate deal breaker because your database needs to be as close as possible to your production application. It needs to be as close as possible to your production blob store bucket because of this like indirect dependency where your application also needs to be kind of close to that. It needs to be close to where you're running your Kafka, which is likely also in AWS. And the moment you run anything outside of that zone, you're hit with extremely expensive networking costs. And you're also just adding unnecessary latency to every user interaction, every backend query. However, that is not the case for CI workloads. In fact, for most companies, your CI is already running outside of your cloud account. Your code already lives in GitHub, which is not, in your. No one really ever used AWS's Git server implementation. I forget what it was even called.
Code something, yeah.
So we realized that CI was a class of workloads that you could expatriate out of the hyperscalers and customers, because it also doesn't deal with their end customer data. It's just code. The security expectations for that are not as BYOC centric, if that makes sense. Like if I'm using a database and I'm trusting a vendor with my customers' data, I do want that to be in my cloud account as much as possible. However, if my code is already not in my, not in kind of my sovereign like jurisdiction, I'm okay with my CI also being out of it. And because of all of this and the fact that, the actual hardware itself is just so much cheaper than what you can get on the hyperscalers. It just made sense for us to start the business off with that kind of understanding and the fact that our unit economics improve as we get more customers. So yeah, I think it's like sort of a confluence of all of these factors. We could consider in the future like a BYOC type offering once our observability piece becomes valuable enough that that's something customers care about. But at the moment, this like trade-off just makes a lot of sense both for us and for customers.
Yep. And then so where are your instances running?
So we have one data center in Germany. We work in another company in Phoenix in the US. We're potentially working on a third region at some point later this year, and that'll likely be in US East, Virginia, that area. The other interesting thing about CI workloads is that for most jobs, they're pretty location agnostic. They kind of just need to be close to your caches. So if we control our customers' cache artifacts, we kind of have a lot of control over where we can place their entire org. And we also have a bunch of control over where we can like move them. However, one exception to that is jobs that perform Docker builds and push Docker images to container registries. Because typically your container registry lives in your AWS account in like something like ECR, which is homed in some region. So at the moment, what we'll do is if a customer has Docker builds running that push to a container registry in the US and US West, we'll home them in the Phoenix data center.
Phoenix. Okay. Yeah, I saw that you all started in EU Central, and I guess that's true. Like, there's not a lot of, going back and forth other than that Docker push. I guess like was EU Central cheaper than hosting in the US or?
Yeah. So we work with a vendor called Hetzner. I think they're sort of fairly popular for just leasing out bare metal hardware. They are fairly reliable. They let you attach high throughput network links to all of your instances, also for relatively cheap. So that was the reason we started in EU Central. Hetzner is only in the EU, at least their bare metal offering is only in the EU. And then over time, as we hit more scale, we had kind of the leverage to start working with slightly smaller data center colos in the US. And we kind of see us going lower down that sort of pipeline over time as our scale improves. At some point, we'll start renting rack space, but racking it up with our own hardware. But yeah, all of these are sort of problems for the future where we explicitly want to improve our unit economics even further.
Yeah, for sure. And so you mentioned, blob storage being essential for the cache artifacts. Are you using something like S3 or Google Blob, or are you using does Herbster have something, or are you running Minio, or I guess what are you running for blob storage?
Yeah, so we offer two types of caching for CI jobs for our customers. One is backed by like a S3 compatible blob store. We run MinIO, which is this open source S3 compatible blob store. And the second kind of caching we offer is something we call sticky disks. And sticky disks are effectively our implementation of like a network attached block device. It lets us offer out of the box Docker layer caching for all Docker builds running on Blacksmith. So for instance, if your CI job builds a Docker image, you can change one line of code to tell Blacksmith that, this job builds a Docker image, and we will transparently mount in this like network block device that contains all of your Docker layers into your runner. And that will asynchronously get committed after your build completes. And it happens completely transparently to you. It can in the most like optimized scenarios, it can be up to 20x faster. However, we do unfortunately find that most customers do not have the most optimized Docker files. So it ends up only being about 60, 70% faster, because that's the percentage of layers that are like cached in any build. But going back to your question, for every cell that we operate, every kind of data center colo that we operate, we run a fleet of machines that run our blob store. We run a distributed storage cluster that runs Ceph that offers sticky disks. And we have our fleet of VM agents that orchestrate virtual machines. And these are all in the same data center. Once they grow past the size of the number of machines we can have in the same DC, we kind of have to create a new cell. And this is to ensure that all the VM agents effectively have like a local link to the cache clusters, because that's like a big part of our value prop.
Gotcha. And how is running MinIO? Is that like pretty straightforward and easy? And is it significantly cheaper than S3?
The way we run it is not particularly cheap, because we also run MinIO over NVMe drives, whereas S3 obviously does a lot of intelligent tiering. Operationally, MinIO has been extremely smooth for us to run. We did initially have some issues when we were sort of like starting out, but once you get through this like initial operational hurdle, it's been relatively smooth for us. Their story around expanding the size of the cluster is also less than ideal. They almost necessitate that you have to take like a minute of downtime to expand the cluster, but that ends up being fine in a lot of cases, just because of how rare these are, and the downtime window is like fairly short.
Yep. And even if that has downtime, does that just mean, hey, this build it isn't using cache and it can still run the build, it's just going to be slower?
Exactly. And we can kind of time it a bit based on the data we have around like when the usage is the lowest. We can kind of time the window in a way where like no one even like notices.
Yep, nice. Did y'all have a lot of experience doing like orchestration on, Hetzner and things like that versus the hyperscalers, or was this new to you, or what was that like?
It was relatively new to us. However, we did have, one of my other co-founders, and a lot of our team is from Cockroach. One of our founding engineers is also from Cockroach. We did have a lot of experience fighting fires with Cockroach customers that were running Cockroach on-prem. Big banks and customers of that nature. So we were fairly comfortable with running a big service on our own hardware. We dealt with a lot of like typical like network congestion type problems over time. So it felt like it was tractable. Of course, the when the rubber meets the road, you encounter new problems, and there's things that you have not dealt with before. But we've actually felt like every time we want to run something that's large scale on something like AWS, at least initially, we're dealing with problems that we'd like rather not deal with. Like I'd rather not have like a full service outage, because my auto scaling group doesn't have the quota limits for that specific instance type in AWS, and I have to contact AWS support to bump up the quota limits. And I would rather deal with problems that we can as a team just debug on our own and fix and mitigate on our own.
Yeah, interesting. Yep. One complaint I hear a lot, and you mentioned a little bit earlier, is just like the network IO cost in like the hyperscalers. Does Hetzner have anything comparable to that? Do they charge or limit you on bandwidth, or what does that look like?
So they have no limits on bandwidth. They do charge you for bandwidth, but it's I'll have to double check myself, but I think it's So for hyperscalers, the egress costs, intra-zone egress costs, are $90 per terabyte. So 90 cents a gig. However, I believe that's right. That might be inter-zone or inter-region. Could be wrong about that. But on Hetzner, it's $1 per terabyte, and that's kind of the typical the typical like network bandwidth cost you'll pay with like a larger ISP.
Yeah.
So a lot of these
interesting. So the cost is very comparable to
Yeah.
hyperscalers. Interesting.
They're sort of just like passing that down to the customers.
Okay.
And that's a huge difference, right? And it's low enough that we effectively just like don't have to think about network costs at all.
Yeah. Okay. Okay, cool. Okay, let's move on to multi-tenancy a little bit. And I would encourage everyone to read the blog post, number one. But the cool thing you all were explaining there is, hey, CI workloads are extremely spiky, where you might have a customer that needs like 500 vCPUs very quickly, and maybe 5 times that if 5 people push code all at once. But if you aggregate a bunch of customers together, it actually smooths out quite a bit to where the individual spikes don't need as much there. And I know AWS talks a lot about like peak to average ratio, where peak is like the max you need at any given time, which is basically like how much you need to have provisioned or else have, queues or outages or something. But average is like what your margins are measured against. I guess, is this like something when you were coming into Blacksmith, you're like, hey, this was like a key selling point? Is this something you like figured out later on about just like multi-tenancy and things like that? Or like when you were sort of conceiving the idea of Blacksmith, was that a big point you were focused on?
Yeah, we knew that our unit economics would be substantially worse in the beginning when we barely had any customers, and we still had to have like a big fleet to support even a small number of customers, because workloads, like you said, are bursty within a customer. However, we knew that like the economics would improve. We actually ran this like Monte Carlo style simulation early on when we were in YC, to just like run some numbers on like what happens when we're running 100 jobs a minute or 1,000 jobs a minute, and then kind of just like project that out. So we knew that if we hit a large enough scale, our margins would be substantially better. We also knew that there would be a path for us to kind of go down the hierarchy in some sense. So we could start off with leasing bare metal machines from a provider like Hetzner, but over time kind of rack our own machines and kind of go down that route. It seems like that's a trend that is also catching on in general in the industry. Like I know Railway, which is like a app hosting platform, they kind of did a similar migration of GCP onto their own bare metal hardware. And I think the quality of service has actually improved as a result of that.
Yeah. Yeah. You're actually the second person I've talked to in 2 days that's using Hetzner for some stuff too. So like, you're really starting to see a little bit of that trend, especially if you have a unique workload or like understand the trade-offs well. And like you're saying, aren't scared of getting into the orchestration stuff and realizing, hey, maybe it's not as bad as you think it is. So I know like one thing is, CI workloads are like somewhat correlated, right? Because it's going to be during people's work days for the most part. I guess, is there anything you all are doing to try and help smooth those numbers or try and make it so people are moving jobs to off hours, either with pricing or even with like customers you're targeting in different regions of the world, or are you just, you'll figure that out later and right now you're sort of in growth mode as much as possible?
We're sort of in growth mode as much as possible. However, we're realizing that the bursty nature of CI workloads is actually getting worse with a lot of these like background agent companies kind of doing a good job, and the model's just getting so much better. We've had customers. We actually have one customer where the way they operate for a lot of kind of product-facing features that have like a well-defined boundary, they'll file a bunch of linear tickets. They'll create like a linear project. They'll file 11 tickets. They'll furnish those tickets with as much detail as possible. And then they'll just like kick off 12 background agents all in parallel, which will, within the span of like the next like 5-10 minutes, kick off like 1,000 CI jobs, because each pull request may kick off like 100 CI jobs, right? So it's becoming more bursty, which we're sort of handling well, and that's like another. I think that's another aspect of, I think, what will make self-hosting CI even harder in the future, because typically the way companies will self-host CI is they'll run like a EKS cluster. They'll run GitHub's ARC controller to manage the runner pods over that EKS cluster, and maybe they'll use something like Carpenter to handle node provisioning and scale the size of the cluster itself as it saturates. We've had a number of customers where that just becomes such a big operational headache for something like CI that's not a core differentiator. It's not a core competency. They just like rather not spend time on it. And as these companies adopt more of these background agents, we see that shift happening even faster.
Yep. How does Blacksmith charge currently? What's the unit you?
So we charge we charge for two things, both usage based. We charge by the minute on the runners for the compute, and we charge for cache storage, the sticky disks that you use. Each customer gets some like free quota for the blob store cache. They also get some free minutes on the compute. For larger customers, we'll sort of just negotiate bespoke pricing. That's sort of another big advantage we feel like we have, where for larger customers, we actually have a lot of leverage in terms of pricing our offering however we want, and not based on just our costs. So a lot of vendors, a lot of folks, I think on your podcast have talked about, they kind of have to begrudgingly do cost plus pricing, just because their costs are so like linear to their like their gross margins are just fixed. And 30% of their revenues just go to AWS, some cases even more. So they don't have as much leeway in pricing their products the way they would want. We don't necessarily have that. Sure, our gross margins are still like a big percentage of our revenue. It's still a double-digit percentage, but it's not. Like our gross margins are not 40%. We're over like a 80% gross margin business. Lets us like price things in a lot of different ways that works well for customers.
Yep. Okay, that's super interesting. And then, can I have as many jobs running at a time as I want, or is there some sort of queue or limit, or what does that look like?
Yes, but we'll have alerting on our end when a customer runs more than 1,000 vCPUs worth of jobs. We'll get alerted, and someone from our team will at least like look at it to make sure that it's not someone that's trying to DDoS the system. Early on, we had instances where people would try to mine crypto in GitHub Actions jobs.
Anytime you have a compute service, like someone's going to try and mine crypto in it. Yeah, for sure.
Exactly. It's kind of silly because these days, crypto mining has become so efficient that unless you're running it on FPGAs or GPUs, it's like completely pointless to run it on CPUs. But yeah, so we'll have alerting on our end to like make sure someone isn't like attacking the system, but there's no real concurrency limits.
Yep, interesting. Yeah, I was just trying to think about that, like to try and smooth out that load, especially with that agent stuff. If there's like some way you can incent customers to like kick that off overnight, where it's like, hey, you have those background, like, there's 12 hours overnight where they can run it at any time, and like your load's super low and can spin those up. But it's kind of like a tricky thing. It's like, you don't want to give, I don't know how you incent that.
We can easily launch sort of like a low priority SKU that like lets the customer kind of defer the scheduling of the job to us, and we can offer like a much lower pricing on that kind of thing. It's something we're open to doing. However, we haven't had like that much like demand for this sort of thing, and that was surprising to me as well. I think typically people just want their like blocking CI jobs to run as soon as possible. for stuff that is not as critical, they're kind of already running nightly in like a cron on GitHub Actions itself. So the demand for like this scenario where they want the vendor to kind of do the scheduling in a way that's disconnected from the orchestration platform, which is GitHub Actions in this case. We haven't had a ton of instances of that yet, but
yeah, for sure. On that sort of AI note too, do you feel like the explosion of coding agents and all that is like a tailwind for you guys because there's just so much more demand for CI now? Or is it a headwind because it's like, oh man, it's that much spikier that we have to deal with and it causes that problem? Or how is that affecting y'all?
So especially for smaller teams or younger teams that are moving fast, are adopting a lot of these tools faster than larger enterprises, we're seeing that our growth rate for companies, even normalizing for sort of employee count, is like over 60% quarter over quarter, meaning that, for 10 engineers, they're running 60% more CI quarter over quarter with, the same amount of people, which, because we started the company like during kind of this whole like coding boom, it's kind of hard for me to juxtapose that with what that would have been before, but that seems pretty high. And almost all of our customers are like, we see a pretty big a spike or surge over the last like few months of things like the cursor agent and like things like Devin and Claude and all of that in our data, just commits being pushed by agents more and more.
Yep. Are you able to see like popularity of the different, like especially like terminal based agents, like which ones? And can you share any of that stuff?
Yeah. We plan on doing a series of blogs on that kind of stuff. Just because it's like interesting. Typically, what happens is whenever there's sort of a big launch. So when Devin launched, there was like a huge spike to the point where it was something like 0.3 or 0.5% of all of our CI. And then, it sort of like goes down and like flatlines, but then maybe it kind of improves over time again. And every time there's a big new model launch with, for example, the Claude 4 series of models, they resulted in almost like a step function increase in how much more people were using background coding agents in general. And I expect to continue to see that with like newer model launches.
Yep. Super cool. Okay. On that same note, similar-ish, y'all just raised a $3.5 million seed round. So congrats on that. VC environment, like super interesting right now because there's so much AI energy, and then y'all aren't like an AI app builder or something like that. Like, was it difficult to break through the noise, or did it help like having this tailwind of like, hey, these coding agents are like probably the most popular AI app right now, and they're going to need a lot of CI. I guess like how did that go?
It was fairly difficult with some VCs. It was fairly easy with others. So it was sort of this like very, very interesting but kind of polarizing experience in some ways, where some VCs wouldn't even want to talk to a company raising a round that's not in AI, whereas the others kind of totally get it. Like they sort of understand the second order effects of all this code gen. Is one of the things is like CI will become a bottleneck. So it was very much based on like who we were talking to and sort of how technical they were in some sense. In general, I would not want to start a non-AI company in today's environment in general, just because all of the air is like being sucked out of the room, and for good reason. A lot of these companies are growing at rates that have basically never been seen before. So
it's pretty wild. Y'all did YC as well. I guess like tell me about your YC. Did all three of you go to the Bay Area?
So we lived in San Francisco for 4 months. YC was quite a great experience for us, honestly, just because they're quite hands off in some ways, but they still sort of keep you on your toes, and they kind of keep you aligned on solving important problems that are important for the business, and not kind of go down on rabbit holes that are not worth pursuing at that early stage of the company. which was quite helpful. You get a bunch of early users, early usage from other companies in the YC batch, which is obviously quite helpful as well. I think if you were starting a company that had sort of immediate demand with very early stage startups, like sort of like a SOC 2 compliance type company, then YC is like the ultimate like jumping off point, just because you can end the batch with like 2 dozen like 8 figures, 2 dozen like sort of 5-figure customers. And we weren't like that because a lot of these YC startups at that stage don't have that much CI. They're barely writing any unit tests at that point, but it's still valuable usage. Yeah, it gives you a big up in the fundraising right after the batch, which was also super helpful.
Yeah, for sure. Did your idea change much in YC, or did you go in with pretty much this idea and come out with this idea?
Yeah, we were one of the, I think we were one of the only companies in our cohort, at least, where we came in with this exact thing, and we are still kind of building this exact thing, where even the thing we sort of pitched in our YC interview was this like compute fabric for CI with all this like built-in observability. And in some sense, we still haven't like fully achieved that, but we're also still like working on the same vision. And I'm glad that's the case, just because the constant shifting of focus can be really detrimental at this stage of the company.
Yeah, for sure. Okay, now you're in New York. Is the whole team in New York?
Yeah, so all of engineering is in New York. All of our growth and sales is in San Francisco. So we have like 2 offices. We're gonna likely grow the team in this fashion for at least another 8 months to a year. But we're open to good candidates in on either coast. So if there's like a great GTM hire that is only open to working out of New York, then we'd obviously make exceptions.
Gotcha. So you want in office and ideally sort of with those strategic hubs, but as long as they're in an office, you're up for it?
Yeah. I think at this stage of the company, it's just so much easier to keep everyone aligned on what's happening in the company, the direction we want to swim in, that sort of thing, if everyone is in person. I find that unless your entire founding team has previously worked with each other before, and it's sort of like like a bunch of team members from LinkedIn leaving to kind of do Confluent, that sort of thing, it's very hard to have everyone be engaged and build mutual personal relationships with each other if you're remote. At some point, we're going to have to be a bit more flexible, but it feels like the correct kind of trade-off at this stage.
Yeah. Are all 3 of the founders more like engineering heavy and associated with engineering, or is one of them, 1 or 2 in SF doing more sales GTM type stuff?
Yeah. So JP, our CEO, he's in SF. He is solely focused on GTM and sales and kind of everything else that needs to be done. Myself and Aditya, who's our 3rd co-founder, we're both sort of focused on engineering, and that's been a good split. We get to kind of protect each other's times and let us kind of do what we're best at. And I find that even the location split is sort of helpful in that like one office is sort of entirely thinking about sales and growth and content ideas and that sort of thing, and one office is sort of entirely focused on product. At least at the moment, that seems really great for our focus.
Cool. Yep. And closing out like on an engineering level, I guess, like what does the code base look like? Is it TypeScript, like you're saying? Is it lower level stuff, or what are you using for that?
Yeah. So we have a lot of Golang. A lot of our infra services are Golang. All of our front end is Next.js, TypeScript, React. Our control plane is actually written in Laravel in PHP.
How interesting. What drove that decision?
We sort of couldn't be happier with this like split in the stack, just because so we built a number of projects before, just sort of personal projects in Laravel. and is just a very productive way to write application control planes, in my opinion. Um, all of the problems that you typically want to solve in a control plane, background jobs, billing, um, um, caching in various parts of the stack, um, queuing various types of jobs in particular kind of sequences and graphs. All of those are just solved problems in a framework like Ruby on Rails or Laravel. Um, Modern PHP, for all the flack it gets, is surprisingly good and pleasant to work with because it's typed now. The tooling around it is really great. The other thing that we didn't kind of foresee when we were starting the project off in Laravel was how good a lot of these coding agents were going to be at generating PHP code. Just because I don't think there's another language that has more training data out there. But at the same time, the framework, the Laravel framework itself, kind of keeps the solution space a bit more constrained. There's typically like one kind of canonical way of achieving something. So these agents will typically write code that looks like the way we would write it. And yeah, it's been incredibly productive.
Wow. Yep. You're the second person that not only uses Herstener but has some Laravel and PHP in there too. So second person in 2 days with that. What's your AI workflow then? Are you using like more interactive like Cursor? Are you using like Claude Code or Codex or more like terminal jobs, agents? Like what do you do?
I'd say half of our team mostly uses Claude Code at this point. A lot of stuff is kind of kicked off with Claude Code, and that gets you 90% of the way, and then the final 10% you sort of finalize with something like a Cursor. But I'd say the other half of the team is like all Cursor.
Yeah. What about you personally? What's your workflow?
I like to like start things off with Claude Code and then kind of take it the final mile on Cursor. And I think that final mile is getting shorter and shorter as these like tools improve.
Yep. Cool. I still love Cursor so much. I haven't tried the Claude Codes, but I'm seeing more people switch to it. I gotta get over to it. So
yeah, it's shockingly good. They sort of dynamically switch between like the thinking mode and kind of the non-thinking mode, and yeah, it's just shockingly good.
Yeah, that's fun. Well, Ayush, this has been great. Like it's been a fun episode, like talking about all this stuff, and I appreciate you coming on and sharing all this stuff. If people want to find out more about you, about Blacksmith, where should they go?
So Blacksmith is at blacksmith.sh. If you're running GitHub Actions, we can likely help you move faster. And if you're spending a lot of money, and if that's a problem, we can likely reduce your CI spend by quite a bit as well. And we think a lot of teams will like the observability features that we kind of already have, and a lot of the stuff that we have in the pipeline.
Yeah, very cool. Now that you say that, I should, like, if I'm switching to Blacksmith, is it like, hey, it's a 2-line change in my thing and everything else should work? Do I have to make some changes to my CI jobs, or what does that look like?
Yeah, so you install our GitHub app and then you point your CI workflow files to Blacksmith. So it's a 1-line code change to run your jobs on Blacksmith. We also have this like nifty migration wizard that will move your entire repository onto Blacksmith in 3 clicks. And that'll apply all of the caching optimizations on top of just moving to our runners.
Very cool. So yeah, easy to try out and see if it's faster, if you like the observability stuff, and try that out. So again, Aayush, thanks for coming on. It's been great. And yeah, best of luck to you going forward.
Thanks for having me.